Now the derivative of the general logarithm log of a with the log for base a and for x, log a for x. The derivative of d by dx for log a for x is equal 1 over the function multiplied by ln the base multiplied by the derivative of the function. Again, d by dx for log a for u is 1 over u ln a multiplied by the derivative of u. For example, if y is equal log 2 for 3x, so dy by dx, the left hand side is equal the function ln of the base, and here is 1, multiply derivative of 3x, and derivative of 3x is 3. So it can be written as 3 divided by 3x multiply ln of 2, and by cancelling 3 it's 1 over x ln of 2. Differentiate each of the function with respect to x. Y is equal 4 to the power 4 x power 4. This is an exponential function, and the old teacher telling us that the derivative of the exponential function is equal the function itself multiply ln of the base multiply derivative of the bracket or the power. So if I wanted to find dy by dx here, for the left hand side I'm going to put down the function itself, which is 4x to the power 4, 4x to the power 4 multiplied by ln of the base, and ln of the base is 4, multiply derivative of the exponent, and derivative of the exponent is 16x to the power of 3, and you cannot simplify it more than that. Differentiate with respect to x. Y is equal 4 to the power of negative 5x power 3. We know that the derivative of a to the power of u is equal a to the power of u ln of the base multiply derivative of u. So dy by dx is equal the function 4 power negative 5x power 3 ln of the base, which is 4, multiply derivative of the exponent negative 15x to the power of 2. Differentiate with respect to x. Y is equal log 3 for 3x squared, and we are saying that the rule is d by dx derivative with respect to x for u is equal 1 over u ln a multiplied by derivative du by dx. So dy with respect to x is 1 over u, which is 3x squared, multiplied by ln of the base multiplied by derivative of this function 6x, and I can simplify 6 divided by 3 is 2, and x power 1 divided x power 2 gives me x to the power 1 in the denominator. So it's 2 over x ln 3. So dy by dx is equal to 2 divided by x ln 3, x ln 3. Differentiate each of the following function with respect to x. Y is equal log 2 for 4x squared. We have a hint here that the derivative of log a for u is equal 1 over u ln a multiplied by the derivative of u. So dy by dx is equal 1 over 4x squared multiplied by ln the base multiplied by derivative of the base or derivative of u. It's 8x. Then 8x divided by 4x square is give me 2 over x ln of 2. So it's 2 over x ln 2. Differentiate the function with respect to x, and we have the rule to the right of the differentiation, and the function is y is equal log 3 for 3x power 5 plus 5 all to the power 5. I can use the properties of logarithm by moving this 5 outside the log, so I can write it as 5 log 3 for 3x to the power 5 plus 5. So now derivative of y with respect to x equal 5 multiply derivative of the logarithm is 1 over the function, which is 3x to the power 5 plus 5, multiply by ln the base, which is ln 3, multiply by derivative the function itself, or u, and derivative u is 15x to the power 4. 15x to the power 4. So let's simplify it. 15 multiplied by 5 is 75 x to the power 4 over 3x to the power 5 plus 5 ln 3. Differentiate with respect to x the given function y is equal log 5 for negative 5x to the power 3 minus 2 all to the power of 3, and here to the right I have the rule for the log or the derivative of the log. But before I'm going to find the derivative, I'm going to write y by using the properties of the logarithm as 3 log 5 for negative 5x to the power 3 minus 2. So I can say that dy by dx is equal 3, it's a constant, multiplied by u, so negative 5x to the power 3 minus 2, ln a, which is ln the base, and the base is 5, multiplied by derivative of u, so it's negative 15x square. So it's negative 45 after I multiply 3 by negative 15 over negative 5x power 3 minus 2 ln of 5. Differentiate with respect to the given function with respect to x. Y is equal 4 to the power of x power 3 plus 2 all to the power of 3. And the old teacher is telling us that if u is differentiable, then the derivative of a to the power of u, the exponential function, is equal a to the power of u ln a du by dx, du by dx. So dy by dx is equal, I know that this is a power chain rule, so I'm going to put down the power, subtract it from the power 1, and keep the function. Then multiply derivative what inside the function, and derivative what inside the function is 4x to the power of 3 multiply by ln of 4 multiply derivative of x power 3, and derivative of x power 3 is 3x square. So I can simplify it only by multiply 3 by 3x square. So I can write it as 9x square multiply 4 to the power of x power 3 plus 2 all to the power of 2 multiply 4 to the power of x power 3 multiply by ln 4. Differentiate the given function with respect to x. Y is equal 3 to the power of x power 4 plus 1 all to the power of 3. This is an exponential function, so the derivative of this exponential function is written to the right. We are going to assume that this function is u. So if we let u is equal x to the power 4 plus 1 all to the power of 3, so du by dx is equal 3 x to the power 4 plus 1 all to the power of 2 multiplied derivative of the function, which is 4x to the power of 3. So it can be written as 12 x to the power 3 multiply x to the power 4 plus 1 all square. So dy by dx is equal the function itself multiply len of the base, which is 3, multiply derivative of the function or u. So multiply 12x power 3 multiply x power 4 plus 1 all to the power of 2. Differentiate each of the following with respect to x. Y is equal 3 cosine 3x to the power of 4. So we are going to assume that the power here is u. So it's written in the same form as the one to the right. Derivative of a to the power of u is equal a to the power of u multiply len of the base multiply by derivative of u. So let u is equal cosine 3x to the power of 4. So du by dx is equal. Derivative of cosine a function is negative sine the same function multiply by derivative of the function or the angle. So it's 12x to the power of 3. It can be written as negative 12x to the power of 3 sine 3x to the power of 4. So I can write that dy by dx is equal the function 3 to the power of cosine 3x to the power of 4 multiply len of the base multiply by derivative of u. Differentiate with respect to x. Y is equal log 5 for tan 4x to the power of 4. Y is equal log 5 for tan 4x to the power of 4. So we are going to assume that this is u. And as we can see to the right here, that the derivative of log a for a differentiable function u is 1 over u multiply the derivative of u and len the base. So I will let u is equal tan of 4x to the power of 4. So du by dx is equal derivative of the tan is 6 square the same angle multiply derivative of the angle, which is 16x to the power of 3. So now I can write that dy by dx is equal 1 over tan 4x to the power of 4 multiply by len of 5 multiply by the derivative, which is 16x to the power of 3 sec square of 4x to the power of 4. And I can simplify it no more, but I can write as a single fraction as 16x to the power of 3 6 square 4x to the power of 4 over tan 4x to the power of 4 multiplied by len 5.